So this question was asked in GATE 2017 Electronics and Communication Engineering paper set 2, in which you have given input and output of a continuous time system related as y of t equal to integration from t minus capital T to t x of u d of u. So you need to find out this whether system is linear or not linear, or time variant or time invariant. So the NPT reference for this question is Principle of Signal and Systems by Professor Aditya K. Jagannatham. You can find the reference in the lecture, which is Properties of Linear Systems. Now, so the useful data for this question is that let's say if you have a system and you put the input as x of t and you get output as y of t. Now, in place of x of t, if you put the input as x1 of t and you get the output as y1 of t. Similarly, you place the input as x2 of t and you get the output as y2 of t. Now, instead of x1 and x2, you put the input as x1 plus x2, that is x1 of t plus x2 of t, that is combination of these two inputs, and you get output as y3 of t. And if this y3 of t is equal to y1 of t plus y2 of t, then it satisfied principle of superposition. If not, then it is not satisfying principle of superposition. So this is the first condition of linearity system. However, you can't be sure from this condition. You need to check also homogeneity principle. So what is this homogeneity principle? That you scale the input by k and your input becomes k times x of t. So if your input x of t give the output as y of t, and if you place the input as k of x of t, then your output must be equal to k times y of t. That is same amount of scaling in the output also. So this is homogeneity, and when a system satisfies both these conditions, when this satisfies both these conditions, then system is a linear system. So this is a condition for linearity. Now coming to the time variant and time invariant, suppose if you are given a signal x of t and you pass this signal from the system and you get output as y of t. Now after that you delay this by amount t naught and you get y of t minus t naught. Now this is the first case. Now in the second case, you take the signal x of t, you first delay it by t naught and becomes x of t minus t naught. Now you pass this signal that is delayed by t naught to the system and you get the output as y dash of t, and if this y dash of t is equal to y of t minus t naught, then system is time invariant, otherwise time variant. So this is the condition for linearity and time variant and invariant. So now in this question you have given y of t equal to t minus t2 capital T x of u d of u. So when you, for linearity, you put input as x1 of u and x2 of u. So your y1 of t becomes integration t minus capital T to t. This becomes x1 of u du, and your y2 of t becomes t minus capital T to limit t x2 of u du. Now you put the input addition of both input, that is x1 of u plus x2 of u, then you will get output as y3 of t, which is equal to integration from t minus capital T to small t and x1 of u plus x2 of u du. So clearly you can see this y3 of t is equal to summation of these two. So your POS, that is principle of superposition, is satisfied. Now the second condition is principle of homogeneity. So for homogeneity, you place the input k times, that is you scale the input and it becomes k times x of u. So when you scale this input, then your yt becomes y dash t, which is equal to k times integration t minus capital T to integration t to t, and this becomes x of u times t of u. So clearly this is your initial y of t. So your y dash t for a scale input, that is k times x of u, becomes k times y of t. So your homogeneity principle is also satisfying for this input output relation. So this system is a linear system. So you check this system is a linear system. So to check the time invariant condition, you first take the x of you first take the signal x of u, you delay it by t naught, it becomes x of u minus t naught, and you give it to the system and you get the output, let's say y dash of t. Now your y dash of t becomes, you have given y of t as integration from t minus capital T to small t x of u d of u. Then you put x of u minus t naught, that is you first take the input x of u, you delay it by t naught, and you get the x of u minus t naught, and you passes through the system. So your y dash t becomes t minus capital T to t x of u minus t naught du. Now in this you put u minus t naught equal to m, then your dm equal to du, and the limit of this m becomes when u equal to t minus capital T, then m becomes t minus capital T minus t naught. Now when u equal to small t, m becomes t minus t naught. Now your y prime t becomes integration, that limit will be changed according to this value of m, which is t minus capital T minus t naught, t minus t naught, and this is your x of m, and this is your d of m. So you get y prime of t. Now you take the system x of u and you just pass through the system and you get y of t, and you now get delay. Now you delay this system by t naught and you get y of t minus t naught. So if this y of t minus t naught is equal to this one y prime of t, then system is time invariant. So you just take this input x of u and you get the output y of t, which is given in the question as t minus capital T to t x of u d of u. Now you delay this by t naught, so it becomes y of t minus t naught, and wherever the t that limits wherever the component t, it gets replaced by t minus t naught. So it becomes t minus t naught minus t, and this limit also becomes t minus t naught, but this u is not dependent on t, this is another variable, so it will not change. So this is becomes only x of u times d of u. So clearly you can see these two equations are similar, that is these two equations are equal. So this is the case of time invariant system. So the system is linear as well as time invariant. So the correct answer for this question is option D.